All right, so hello everyone. Welcome to the webinar. I think we can slowly get started and get settled. Let me maybe first kind of introduce the platform. So we are two companies here. I'm from UgCS. We are the makers of UgCS ground control software. The company is called SPH Engineering. We'll also demonstrate our software later on in this webinar. And we're also joined by the company Pergam. I'll be talking together with Paolo, who's the managing director of Pergam in Italy. Paolo, your microphone is muted.
Okay, sorry.
Yeah, that's perfect now. Then maybe I'll also can quickly tell you about the Zoom webinar platform to those who haven't yet used it. So basically, there's the Q&A section, and there's the chat. In the chat, important thing is that when you write something, make sure to select to write it to send the message to all panelists and attendees. Otherwise, if you only send it to all panelists, then only me and Paolo will be able to see it, but you won't be able, to communicate to one another. If you have any questions, which I'm guessing you probably will during the webinar, then we have a Q&A section, and it's important that you put all the questions there rather than in the chat, because in the chat they somehow might get lost. So if you have some questions at some point, just put them in the Q&A section. We have Alexei here from UgCS and Semen from Pergam. They're going to help with answering the questions, and also we might answer some questions in live. So that's it about the platform itself. Then I think we can slowly get started. So Paolo, I see you're sharing your screen now, and basically Paolo's first going to talk a bit about Pergam, about what it is that they do, about gas leak detection, and then we're going to move on to UgCS part, and then I'm going to talk more in detail about how you can basically use drones to monitor for methane leaks. So, okay, and I think we can slowly get started. So Paolo, maybe you can start by telling a bit about what it is that you do and what you've learned over the years.
Okay, so first of all, welcome to everybody, and thank you for attending this webinar. So my name is Paolo Romanenghi. I'm here to represent Pergam Group. Pergam Group is a multinational group with their own offices in 3 continents. We have offices in the US, in Europe, in Russia, and former Soviet Union. Our activity has been focused since many years in the laser technology for remote gas detection, apart from other NDT, non-destructive test technologies. So the reason of developing such a system is that actually methane is everywhere, whether we realize it or not. We have methane in plants, in storage areas, in compressor stations. We have it under our streets. We have it in the landfills as well. For this reason, it's important to be able to detect these possible leaks out of these facilities, these installations. So the concept of the laser to detect methane is basically based on the frequency of the laser, which is absorbed by methane. So we have a laser diode, we have a laser beam generated by our system, aiming normally to a reflective surface, which can be the land if we're detecting from the sky, or could be any solid reflective surface. When the laser returns to our system, the system compares the intensity of the laser when it was emitted and the return laser to identify if there was absorption. The laser, as I said, has a specific wavelength which is absorbed by methane, and if the intensity of the laser is reduced when on the return signal, it means that the laser has crossed the cloud of methane. And that comparing the 2 data is also possible to estimate the concentration of this cloud. This is just to have a very quick overview of how the technology works. So, as everybody knows, we have many different possibilities to detect methane. There are different technologies in use in the market. So why use a remote detection technology instead of other traditional way? So as I said, the remote technology, this is actually a graphic image to explain what I just said. So the remote technology can be actually adapted to different applications. So as you can see from the images, we have fixed installed systems for facilities. We have a handheld transportable system. We have vehicle-based. We have helicopter-based. Since many years, Pergam has been carried out many surveys everywhere in the world to inspect gas pipelines from helicopter. The helicopter basically flies on top of the pipelines, even if they are underground pipelines, and detect the presence of a higher concentration of methane using the system called ALMA, Airborne Laser Methane Assessment.
Sorry, maybe I can ask you one question about this.
Yeah.
So what's normally the altitude at which the helicopters fly during these inspections?
So of course, this depends by the environment. Normally we fly, let's say, 60 to 70 meters from the ground. So as I said, helicopter-based inspection can be very efficient if we talk about long distance. The cost of helicopter is clearly affecting the total amount of the service.
And so, what do you think would be the main disadvantages of using a methane detector on a helicopter?
So main disadvantages, I will say, from the one side, could be the cost if it's not justified by a distance, a certain amount of kilometers to be covered. On the other hand, is of course the safety. Helicopters are not allowed to fly anywhere, especially in residential area or restricted areas. So for this reason, this actually was kind of interaction to get to the point. Why UAV for methane detection? UAV is not very popular for different applications. It's now very common to find UAV for any kind of business. So from the cooperation we had between Pergam and UgCS, we developed this system for UAV. Following your last question, why UAV instead of helicopter? UAV is definitely much cheaper than helicopter to fly, is more flexible, and is normally easier to fly in potentially risky areas. So if we talk about gas facilities or residential areas, it's easier to have the authorization to fly a drone instead of an helicopter.
Right, because in case something does go wrong, then a helicopter obviously will cause a lot more carnage than a drone. Excellent. So it's a lot safer to, let's say, fly near to buildings and to other infrastructure objects.
So exactly that. So especially if we talk about the application, we've already developed several projects using drones with the laser gas detector, and the application can be several. And if we compare with the application of helicopter, we can say that they are not really competing, but they are complementary.
So, right, so you basically use one system for a certain application and the other one for another one. So I guess when you need to do really like long distance, then you maybe use a helicopter when it's like safe to fly over that area. But when it's more closer to some infrastructure, then it's better to use drones.
Exactly, that's the point. So going more deeper in a possible application could be survey of inaccessible or limited areas, like a facility or a fenced area, or other application we've been working on is landfills. As you know, landfills generate methane, generate emission of gas, and it's important for companies managing these landfills to map this area to identify the points where the gas emissions are more concentrated than other. This is the typical application where the drone is definitely the best solution available. It's possible to create a grid, so fly the drone automatically or manually with the operator if the user prefers, and then create a grid and generate a map of the area with the point of concentration. So the software from from the laser can then create a map and show clearly on this image where the gas was detected, what was the concentration, and give a clear instruction to the operators to act accordingly.
So basically, it matches up from the flight the coordinates of where the drone was at that certain point, together with the measurements. And if some measurement is above a certain threshold, from what I understand, then basically it will show up as a gas leak.
Exactly. So it's possible to adapt the what we call alarm level. So what we call a gas leak, of course, it needs to be above a certain level. If we go to gas facility, we have, of course, a constant presence of methane. When we generate an alarm or a point of attention is when we go over a certain concentration, which we can set. We can define the concentration of interest in any case. It's easily settable. So talking about different technologies, so I guess most of the attendees of this webinar are familiar with the gas leak detection, some of them with drones, some of them with both the situation. One of the questions we receive quite often is why laser instead of a thermal camera, an optical gas imaging camera. So again, these technologies are, from a center point of view, complementary. The limit of the UgCS camera, especially on a moving platform, is that the optical gas imaging camera, thermal cameras for gas imaging, requires some time to be able to see the cloud of gas moving, especially when the concentration of this gas cloud is limited. If we talk about a huge cloud, of course, everybody can see it and probably hear with on ears. But if we have a small leak, which is most of the time most important to find, UgCS camera is not always so easy to use and requires a certain experience. If we install an UgCS camera on a moving platform like a drone, sometimes become impossible to detect a gas leak while moving.
So basically what you're saying is that using a camera like that would be a lot better if it would be, let's say, statically mounted somewhere like on a tower, right? But on a moving platform, it's a lot more problematic to detect simply because it needs more time. So
exactly. That's the point. So the camera requires sometimes, the operator using the camera requires sometimes to be able to see the moving pixel. So basically what the UgCS camera does is showing the moving pixel on the base of on the opacity of the gas at a certain wavelength. So as I said, laser and UgCS cameras are, from a certain point of view, complementary technologies, because if UgCS camera requires time, on the other hand, we have a laser, which is actually a real-time technology. So as soon as the laser crosses a gas cloud, we have an immediate response. So we can immediately have a signal stating that we are detecting this gas. At this stage, we can think about the UgCS camera. So we know where to aim and use an UgCS camera to have, let's say, an image of the cloud. So to identify exactly what is the component leaking. So in this way, the two technologies can be complementary.
Right. So for instance, you would use, you maybe first use the laser detector, and then afterwards, if you know that something is there, you might use a camera like statically somewhere, and
exactly.
then you would kind of see, I guess, the outline of it a bit better.
Yeah, the idea would be actually this one. So to keep the drone on hovering, so in a static position, and then take advantage of the image to see if the concentration is enough to be visible with the UgCS camera.
Right. And so what's the maximum distance for the laser measurement device at which it can detect methane leaks?
So for laser, we have different systems. If we talk about drones, especially commercial drones, lightweight drones, the recommended distance is 25 meters, 25 to 30 meters. Then, of course, we have a higher distance technology. If we talk about helicopters, of course, we can go to to higher distance, to higher altitude. But for commercial drones, and we're talking about drones that can be easily found everywhere in the market, and kind of drones we actually focused for this kind of development. The distance would be about 25 meters from the ground.
All right, and what about the speed of the survey? What would be your recommended speed at which the drone should be flying?
The speed that varies by the let's say the situation. I would say depending how deep we need to go in detail, but yeah, on average we could fly, I would say 20 to 30 kilometers per hour,
right,
on a linear movement, on a horizontal movement.
And I think we're also going to demonstrate that a bit later on in the webinar.
So what else? Talking about the cooperation we had with UgCS, this was an important and interesting project because, of course, we already knew the technology of laser, and the partnership with UgCS allowed us to create this system with a, let's say, more complete, more user-friendly package that can give a kind of added value. And then Alexei will explain better once I'm done the technical concept of data logger developed by UgCS, and how this system can actually give very good results to the customer, so without any added work from the operator.
Right, so that's, yeah. So let's maybe switch the speaker. So if you're done with your part,
yeah.
Paolo.
That's done for my side, so I leave it to Alexei to talk more about the technical part of the system.
Yeah, I think maybe I'm going to cover it, and what's, because Alexei, I agree that Alexei is basically going to be answering the questions that the attendees might have. Welcome those who joined a bit later on in the webinar. I'm just going to kind of repeat myself a bit and tell you a bit about the Zoom platform. So if you have any questions, please put them in the questions and answers section, so just so you know they don't get lost, and so we manage to answer all of them. The webinar will also be recorded, so later on you'll also be able to access it on our YouTube channel, UgCS TV. And basically, also, if you write something in the chat, then make sure that you write it to all panelists and attendees, just so everybody can see it and not just us panelists, unless, of course, you want to send a message only to us. And so, right, I think I can slowly switch over to my screen and then basically show the presentation on my screen. All right, so I hope you can now see the window here. There are three images in this window. So on the left side, this is UgCS ground control software. So this is software that we developed that you can use for controlling your drones. You can control either one or even multiple drones simultaneously. And we also offer command center solutions, which means that you can actually monitor the video from afar. And in this project, we integrated our mission planning software together with the data logger, as well as the Pergam gas leak sensor. So the way it works is that the gas leak sensor, it mounts underneath the drone. And then we have the data logger, which basically matches up the GPS coordinates of the drone with the data coming from the gas detector. And we also have a specific like other software component that shows you the data in real time. So you can see what's the current measurement, and you can set the measurement threshold. And if that measurement is above a certain threshold, then you will be able to see it. Let's move on further. This is kind of how it looks like, the whole system integration. I'm a bit further, I'm also going to show a video so you can see how it works in action. But basically, you can think of this is basically the drone side. So this is the DJI flight controller, the GPS receiver, as well as the light bridge. So on board the drone, we have mounted our own data logger. So it communicates directly to the A3 flight controller on the DJI. This system is currently compatible with DJI M600 and DJI M210. So basically DJI Matrice drones. So on the data logger, we are running our own onboard software. And what it does is it communicates to the payload, which is either, let's say, in this case, it's a methane detector, but we also work with ground penetrating radar systems, and we also work with metal detectors. So it communicates either over Bluetooth or Wi-Fi or Ethernet or UART. And also what we have is we have true terrain following. So this means that the drone has a laser altimeter mounted on it. And what this allows you to do is this allows you to fly according to the actual terrain exactly. Otherwise, oftentimes when you see terrain elevation data in the mission planning software, it might not be as accurate or as up to date as what you would be seeing there on the ground. So this is why we added this to our system. And so the top part, this is the drone part. This is what's happening on board. And so on the ground, what you have is you have a laptop on which you're running UgCS client as well as the server, as well as the custom payload monitor. So this is the software component in which you are able to see the data coming from the methane sensor in real time. So the laptop, it's communicating over Wi-Fi to an Android device, over Wi-Fi or Bluetooth. So an Android device that's plugged into the DJI's remote controller. So just so you can see where the drone position is, and so you can send the mission to the drone through this. So basically, the way it works is that you make the mission on the laptop. So you make the route where the drone is supposed to fly. Then you upload it to the drone, and then essentially you just launch the drone on mission, and then you can monitor live data. And you can choose whether the drone should fly up at a certain set height or should try to follow the terrain. So this is the data logger. As you can see, this is the sort of payload that the drone is carrying besides the sensor itself. So it has a few ports, so namely Ethernet. It has an antenna connector for connecting to over Wi-Fi or Bluetooth, LEDs, power output, and power input. So overall, quite simple, at least on the top part. Then there's connectors to basically connect to the drone's autopilot, also to connect to the laser altimeter, and to connect to the payload if the connection to the payload is wired. And as already mentioned, we support DJI M600 drones, so normal M600 and M600 Pro, as well as the A3 based drones, which basically if you mount the DJI A3 flight controller on another drone platform, you can also use that. And also the DJI M210 and 210 V2 drones are also supported. And also now, quite recently, we added Pixhawk to our supported drones. So this means that a lot of custom drones which are running the Pixhawk autopilot, they are now compatible with our solution. And now I can demonstrate the UgCS mission planning software itself. So you can see it in action and you can see how it would work. So let me just quickly change the screen. Okay, so I think that now you should be able to see UgCS mission planning software. And maybe let's jump to another area. So here you can see an area that's actually a gas pipeline over which we flew. And this you'll be able to see later on in the video. So there's a lot going on here. So let me just make that a bit more clear. So first, we can hide what's not necessary now. So let's hide the root of the drone. And you see these place marks and these red lines. The red lines are actually gas pipelines. And the yellow points, these are the lightning rods. So UgCS, it supports KML file import. So if you already know the location of gas pipelines, you can actually import them. So you will be able to see them in real time as you're flying. So if you go here to map options and map layers, then over here in place marks, here you can see I have the lightning rods. So you can just easily remove them and add them back as needed. And you can do the same with 2D objects. So in this case, this is where I'm seeing the gas pipelines. And so you can remove them. And let's add them back just so we can see them. Just kind of a brief overview of UgCS software itself. So it's basically designed to work with a lot of different autopilots, so Pixhog and most DJI autopilots, as well as some custom autopilots as well. So the whole software, kind of to explain it on a high level, is divided into two parts, right and left. On the right part here, we have the drones themselves. So currently you're only seeing one drone. This is just an emulator, and you can add more drones here. And when you connect a new drone or a new vehicle, then it will appear here. And here on the left side, this side deals with mission planning. So here you can see various different routes that I have. You can show them, you can hide them. And basically, if you want to create new routes, it's quite simple. So you can just add one here. And then simply you can click on the map to add new waypoints. So kind of like that. Okay, now let's get back to where we were. So this is basically how you can see how the route would look like if you would fly over the gas pipelines. So the altitude at which we would fly, as Paolo said, that would be about 25 meters. And the speed at which we normally fly, at least to reliably detect gas leaks, it's about 2 to 3 meters. So let's go here. So you can see now this altitude is set lower, so you can just select all mission segments and we can adjust it. So we can set that, for instance, 25 meters. You can see how all the waypoints are now raised up to 25 meters above ground level. And also the flight speed, you can adjust it, let's say 3 meters per second, and you can change the turn type as well if necessary. And then simply, once you have a drone here in the software, then you would need to upload the mission to the drone. Obviously, you would see the drone after you would connect it. But since you just have an emulator, then let me just quickly upload the mission here. Let's set the profile for it. Yeah, and now let's upload the route to the drone. So you can see now the drone has appeared. And we can simply click arm to arm the drone. And then we can click auto mode to launch the drone on the mission. And that's basically how simple it is to launch a drone on the mission using UgCS. And this is just a normal linear mission. And I think now I can also actually demonstrate to you how you can scan an area, how you can make an area scan mission. So while this drone is doing its job, what we can do is we can move to a different location on the map, and there we can demonstrate how to make area scan missions. So here, let me just go to map layers. I have actually a map overlay imported, which is another feature of UgCS. So let's click focus here. And so here you can see a map. This was actually flown by a drone previously, and then the map was stitched together using UgCS mapper software that comes together with normal UgCS. So you can see, if I zoom in, you can see in quite a lot of detail. So for instance, you can see a car there from the pilot that was flying the drone. And now, for instance, if I remove this overlay, you can see that you lose a lot of detail like that. So what would be the suggested way in many cases? Let's say if you need to scan some industrial area, then it would be actually good to first maybe fly with a drone just to take pictures of the area, then stitch the map together. And then once you have a ready-made map, then you can already plan the next mission with a lot more accuracy, because you can take into account the objects that are actually there. So that's the area that we're going to fly in. And now let me just demonstrate how you can make a quick area scan mission. So let's make a new one. Let's name it area scan, for instance. And here you can see you can have various mission planning tools. So you can have the waypoint tool, the takeoff tool, photogrammetry, area scan, circle, perimeter, and others. So for instance, let's select area scan. And then let's select this area here, just as an example. Okay. And now what we need to do is we need to set the side distance. So for instance, let's set the side distance as 5 meters, the flight height as 25 meters, and the flight speed, let's set that, for instance, 3 meters per second. Okay, and here you can see now a simple area scan mission. You can see it's now a bit turned towards this direction, so we can actually straighten it. So if we change this direction angle here, then, you know, once it calculates, then you can see it's a lot more straight. And it basically corresponds to how this, this road is going. So you would always want to make the mission so that the longest survey lines are basically parallel to whatever kind of lines you have here in the map, just to make it more efficient. And then the same way, just to upload it to the drone, it's quite simple. So let's just disarm our hemicopter here. Then once you click upload, it will jump here on the map. And then just click arm and auto mode to send the drone on the mission. So the software itself has a lot of functionality. It has more functionality than we can cover in this short webinar. But we have a lot of tutorials also on our YouTube. So if you want to, you know, see more, then you can do that. You can actually also download our software from the site just to see it, kind of maybe get acquainted with it, see if you like it. And I think now we can perhaps move on to showing the video. So I can show you the video of how we flew the survey at the gas pipeline site. And also then I'll be able to show you the software component that's responsible for looking at the gas sensor data. And then you can also see how the all the data looks in post-processing. Oh yeah, I'm just seeing some questions there. So yeah, the webinar is being recorded, so that will be available on YouTube for you to re-listen to it. Oh, so there's a question, what's the weight of the drone? So yeah, the weight of the drone depends on what drone you're using. So let's say for the M600, I think it's about 15 kilograms with the payload, if I'm not mistaken. And Paulo, how much does the sensor weigh? Your microphone is muted.
Okay, sorry.
Yeah, that's good.
So the weight of the sensor, including battery, is about 700 grams.
Yep. Okay. So basically, below, so it's below 1 kilogram. And I think if I remember correctly, the DJI M210 and the M600, they have a payload capacity of about 6 kilograms. So it's more than enough, and basically it doesn't really shorten the drone's flight time too much. So, okay, let's see if there are some other questions that I can answer before we transition to the video. Okay, I think we can maybe now move on to the video section. So let me share the screen with you. Okay, I think now you should be able to see the video from the drone. Oh, the video of the drone. So here you can see this is the gas pipeline site. And so basically this is how you arrive somewhere approximately here. And then these are the lightning rods that I showed you in UgCS software. And then you can fly with the drone over here. In the video, actually, we flew a bit further, kind of beyond these towers when we were shooting the video, but you'll be able to see that. So there are the operators arriving with the truck. And this test, we just placed you can see we placed this methane container here and just open up the valve a bit just so we can see the leaks in the test. So here you can see the sensor itself, how it's attached to the drone. So it communicates directly to the UgCS data logger. So we also use altimeter to get true terrain following when we need it. And also this helps you avoid any obstacles in the way. And let's say if suddenly the terrain goes a bit higher, then the drone will also go a bit higher, not to kind of slam into anything. So just inserting the batteries here, turning the sensor on. And then you can see the drone's already being sent on the mission. So let me just pause here. So here you can see UgCS software, same like I showed you just a second ago. And here on the left side of the screen, you can see the custom payload monitor, in which you can see the live data coming from the methane sensor. So you can see what is it measuring now. So you can see we can set a certain threshold there. So in this case, the threshold was set to 1000. And so all the values that would be above that, those would appear in red. And also the data would be saved so that later on, when you stitch it together, you can see at which coordinates was the measured data a bit higher. Obviously, the video is sped up here, but the drone was flying up at about 3 meters per second. So you're just moving to the end of the survey line. I think here is, yeah, so you can see here it's detecting a methane leak. So you can see how the value jumped up from about 100 where it was in the beginning to about 2000 words here. So you can see also the payload status in the Android app. So this is the Android app interface that you would see. So this is the this would be seen on the device that's mounted on the remote. So basically, you can have two people. You can have one person who's the pilot who's flying the drone, so he can also monitor the gas leaks, and you can have another person sitting by the laptop who can also see what's happening on the UgCS mission planning screen and what's happening in custom payload monitor. Oh, see, there's a question about the external altimeter. Is it mandatory? No, it's not necessarily mandatory. It's an option that you can choose to use if you want to. But if you think that you're not going to fly too close to the terrain, then you don't necessarily need to use the altimeter. So you can basically use the methane laser methane detector and our custom payload. So here you can take a look at the results in this software. So you can see the path of the drone, the GPS coordinates, and you can see where the gas leak was kind of measured, and you can see the value that's there. So it has a GPS coordinate together with the value here. Yep. So that's basically it regarding the video. So I think now we can kind of jump over to the questions and answers section, because I think we have covered most of the stuff that we wanted to cover. So let's see, Paolo, maybe you also have some comments on the video and what was shown here.
No additional comment. I mean, I think you explained it very well. So I think everybody could see how complete and user-friendly can this system be for user.
Yep. Okay, let's then see what's in the chat and what's also in the Q&A. Well, I think you mentioned also in the slides, there's actually a question about a fixed wing UAV. I think you were showing a fixed wing UAV in the presentation itself. So I guess you have also tested a methane sensor with that, right?
We do have methane sensors of yes, fixed wings. Is a kind of a larger system we tested. Is a different system than the one we're talking now. It's a larger system able to detect methane above 100 meters from the ground with a much faster speed. So yes, we did a test with the fixed wings drone as well as a fixed wings aircraft.
All right, and maybe I can also kind of plug in here that since UgCS is compatible with Pixhawk-based autopilots, then basically any fixed-wing drone with a Pixhawk autopilot could be used with UgCS software. So it's not only multi-rotors that we support. Okay, so let's see what else. So guys, at this point, if you have some questions, then just feel free to put them in the Q&A and we can try to answer them live. I see there was a question about micro drones. So micro drones also, yeah, it's supported by UgCS. Even though in this case, we don't really have an integration with them. So if you want to fly with the gas sensor, so basically, as I mentioned in the presentation, you'd want to use your DJI M600 or DJI M210 or Pixhawk-based autopilot. Oh, there's actually quite a good question. I see. Paul, maybe you can also actually try to answer this live. There's a question from Kohei. He's asking, how does wind affect gas detection measurements?
Yes, basically, wind actually affects the gas detection measurement because wind, when blowing, spreads the cloud, so it reduces the concentration of the gas cloud. So this is not really related to our technology, but is a problem that everybody working with the gas detection absolutely clear. So when we have a leak, especially from underground pipelines, as soon as the gas comes to surface, if it's blown by a strong wind, it doesn't have the time to generate a concentrated cloud. So basically, it becomes more difficult to be detected. So according to specification of, I would say, most of our gas companies, the inspection specification declare that is not allowed to carry out gas inspection if the wind blows above a certain limit. Some companies declare 10 kilometers per hour, 10 knots, sorry, some of them even less. Our system has been tested to detect gas cloud up to 20 knots wind, which is a rather strong wind, I would say.
Yep. And so kind of a follow-up question to this. So the sensor that we see here in the video, so you can see this basically, it only measures what's directly underneath it. And you probably know there are also like drone LiDAR systems, which they're used, of course, for different application. But in the LiDAR system, basically the laser is moving all the time. So is there some system like that where also the laser itself, it's kind of being moved all the time, just so you can build like, not necessarily build a 3D model, but just so you can get more data, and you can, let's say if the wind starts blowing a bit stronger, then you have a higher chance of detecting the leak, even if it's a bit to the side from and not directly underneath the drone.
No, I mean, I will separate the 2 points, the wind and the scanning. So at the moment for drone, the solution we have for drones is basically a single laser. It can be aimed vertically down the drone or can be bended depending on the situation. The point is that if we consider a pipeline, we are not really looking for the pipeline. So the underground pipeline with the leak will probably, I would say, the leak will not be shown exactly perpendicularly on top of the pipeline. So the gas will try to escape from the soil, finding the easiest way. So the leak may be shown even a few meters at the side of a pipeline. What we do when we fly drones or when we fly inspection pipelines is normally to fly a few meters downwind from the pipeline track. This because when the gas comes to the surface, it will be blown from the opposite direction by the wind. And what we need to do is intercept the gas cloud. We are not expecting to find the exact point of leak flying with the drone 20, 25 meters on top of the pipeline. But we want to limit the area of interest to a few meters around the leak. So,
right. So basically, when you would arrive there on the site, you would first have to kind of identify the wind direction, and then you would have to basically move the mission a few meters into the direction of the wind, so that if there's a gas leak and the gas is being blown to the side a bit, so then you have a higher chance of detecting it.
That's the point, yes. And to identify the wind direction is normally easy, just looking at the leaves moving or grass, or if there is a flag somewhere. So we just need to know what is the direction blowing and fly a few meters to take advantage of the wind. The intensity, so the strength of the wind, the velocity of the wind is not really related to the position, but is actually to the concentration of the gas. So if the wind is blowing too fast, there's basically is changing the conditions. So a leak with a potential high concentration will be shown like a lower concentration leak just because the gas is spread by the wind.
Right.
So, and going to your question about the scanning, so for drone, we have this light solution. Is not a LiDAR, is a laser detector. So as I said, the purpose of the system is to identify the position of areas with higher concentration of gas. Then, of course, is not doing all the jobs. So at the end, once we have limited the point of interest to specific areas where the concentration is high, ground crew will definitely need to make an intervention and probably dig, especially in case of underground pipe, to identify and measure precisely the entity of the leak.
Right. So as you mentioned earlier, so basically gas leak detection, it's a combination of different systems and different approaches working together. So let's say you can have helicopters moving, then you can use drones in some tighter areas where it's not maybe possible to fly over with a helicopter, it might be dangerous. And then once you detect that, then let's say you can either use some cameras to maybe see more the shape of the cloud or how it would look like. And of course, you would also use people with ground equipment to kind of try to get to the leak and well, hopefully, close it down so there's no leakage.
Yeah, exactly. That's the point. So to make an accurate job normally requires a combination of different approaches.
So there was a question about calibration. So is there any necessity to do the calibration of the sensor before doing the flight?
No, the sensor self-calibrates. So every time you start the sensor, it takes about 1 minute to make a self-check and self-calibrate. There's an internal cell that is used by the system to make self-calibration. So it's not required to make an external calibration before the service.
All right. So in this case, basically the drone is the most unreliable component in the sense that for that one, probably if you go to some new location, you would need to do some calibration. So the sensor is quite more reliable in that sense.
In that sense, yes, I would say, yeah.
So let's see what other questions we have here. Oh, so there's a question. So can you basically use a camera to detect the gas leak together with the laser simultaneously?
Yeah, as I said, the camera and the laser are basically complementary systems. We've been carrying out some tests with the combination of the two systems. As I said, the OGI camera, the thermal camera for gas imaging, requires some time to be able to detect especially small leaks, while the laser is a real-time system. On the other hand, the laser detects a cloud. It may not be so precise to identify the exact point of origin of the gas leak. So in this sense, I will say that the right combination will be to use the laser to identify the area with the high concentration of gas, so the gas cloud. And once identified the area of interest, use a camera to identify the point of origin of this leak.
Right. So basically, you would not. I guess the kind of takeaway from that is that you would not use both systems simultaneously. But you, let's say, first use one, and then you can use the other one to kind of make sure that the data was correct, that there is a leak indeed, and kind of get a more clear-cut shape of it.
Yeah. Another point, if we want to add an added value of this kind of combination, is that especially OGI camera with cool sensor as kind of a limited life. So there are active components inside. There is a compressor with a limited working hours, and it's a rather expensive component to be replaced. So in this case, we can keep the camera off and start the camera only in presence of a detection. So we can also extend the life of the sensor, of the camera.
Right. Okay, so I'm seeing a few more questions there. So one is, do you require both a laptop and Android device to fly the missions? You require both to plan them. But so what you can do is, for instance, with UgCS, you can plan the mission before you go into the field with the laptop. And then you can already upload it to the Android device. And then once you arrive there in the field, then you might not even need to pull the laptop out. So what you can in theory do is that you can simply just, on the Android device, you can just click to start the mission, and then you can fly with the drone. However, it's at the same time, it's useful that you can see the custom payload monitor at the same time while you're flying. So you can see the measurements coming from the device. Even though you can see them also on the Android device, another aspect is that quite often when you arrive there on site, you can see that some things are a bit different. So let's say you might need to, for instance, move the first waypoint closer to where the drone is, or you might have to adjust the mission. So in this case, it's still good to have the laptop with you and use it kind of together with the Android device. And yeah, there's also a question about the data logger capturing the leaks. So basically, yeah, all the data coming from the sensor, it's put together with the data in the data logger. So basically, all the sensor information, that's all geotagged. So there's another, so yeah, georeferenced. Another question is about, yeah, amount of training necessary to use the system. Actually, we do trainings for, let's say, for a custom payload for a ground penetrating radar. And there it's like the data interpretation that's a bit harder. And that training takes about 3 days. So I think in about 2 days of training, you can get kind of acquainted with how to use it, how to use the drone together with the sensor. So it's not too difficult to learn. Okay, so let's see if there's anything else at this moment. But I think basically most questions are already answered. Those who haven't been answered, we will answer them after the webinar. And also we have contacts from all of you guys. So the webinar recording, as I already said, that will be available on YouTube. So we'll send you the link so you can see it and you can rewatch it if necessary. Or maybe if, let's say, one of your colleagues missed it, then you can kind of come back to it and watch it later on. And I think at this point we can probably try to wrap it up a bit. So Paolo, I would like to thank you so much for joining us in the webinar. It's been a real pleasure talking to you.
It was my pleasure. Thank you for this opportunity, and thanks all the attendees.
Yeah. So thank you everybody for joining us, and hope it was very useful for you. Hope you learned a lot. And let's stay in touch after this. If Paul, maybe you can also give some kind of contacts from your side if someone wants to contact you after the webinar.
Yeah, I will now put the contacts for any additional requests. So in general, you can address to our office. We have a general email address, which is info@pergamitaly.eu. I will send the contacts anyway for any additional question.
Yep. All right. Perfect. And so for us, we'll also send you our email contacts. So if you're interested in purchasing the system or seeing how it works, finding out something more, then let's just let's stay in touch and let's keep working. So all right. Thank you everybody for joining, and I think that's it for today.
Thank you.
Yep. Thank you.